Good morning. This is Mrs. Wyrick with a video on how to find the greatest common factor of two or more numbers. The first way we can look at is to find all of the factors of the two numbers and put them in a list. So the factors of 12 are 1, 2, 3, 4, 6, and 12. All of the factors of 36 are 1 times 36, 2 times 18, 3 times 12, 4 times 9, and in there's also a 6 times 6. And since we only have one number being multiplied times itself, we're just going to write the 6 once in there. Okay, so here are all of our factors for 12 and 36. Now we're looking for the greatest common factor. So let's start comparing factors. They have a 1 in common. Let's see if there's any greater factors they have in common. They have a 2. They also have a 3 and a 4 and a 6. Well, they have a lot of factors in common. Do they have anything greater than 6 in common? They sure do. They have 12 in common. So their greatest common factor is 12. All right. Now, let's take a look at a different method for solving or finding the GCF of two numbers. We can also use the prime factorization of the numbers instead of listing them, because sometimes once my numbers get so huge, they could actually have more and more and more factors, and my list would just be way too long to have to write down in a line and then compare the two lists. That might take forever. So let's figure out a way to use the prime factorization of two numbers in order to find the GCF of those two numbers, or the greatest common factor. So I'm going to go ahead and factor out 60 into 6 times 10. And 6 and 10 are both composite, so I'll need to factor both of those. And the factors of 6 are 2 times 3. And they're both prime, so I'm going to go ahead and circle them. And factors of 10 are 2 and 5. And those are also both prime, so I'm going to circle those. Now for the writing my prime factorization part, I see a 2. So I'm going to write a 2. I also see a 3, and I see a 5. Now for my exponent parts, I see two number 2s, so my 2 needs an exponent of 2. And I have each a 3 and a 5 just once, so no exponents for that. There's my prime factorization for 60. Now how about 45? Factors of 45. 3 times 15. 3 is prime. 15 is composite. So this is 3 times 5. And these are both prime, so I'm going to circle them. All right, now for writing my prime factorization, I see a 3 and a 5 in my circles. They're being multiplied. But I see two number 3s, so I need an exponent of 2. Now we need to take a look at their greatest common factors. 60 has a factor of 2. In fact, it has two factors of 2. 1, 2. 45 doesn't have any factors of 2, though, so we're going to leave the 2 out. We're not going to be using that. Let's take a look at the next factor. 60 has a factor of 3, and so does 45. In fact, 45 has 2 of them. But how many 3s are used as a factor in common? This one only has 1, and this one has 2. Can this one have 2 in common with 45? No, because it only has 1. So I'm going to go ahead and write 1 number 3 down. Times, well, let's look at our 5s. Look, they have a 5 in common as a factor. So I'm going to write my 5 down. So that means that their GCF, or their greatest common factor, is 15. One last way to find the GCF of two or more numbers is to use the birthday cake method. The birthday cake method is used like an upside-down division problem. Take a look. I have 66 and 99 here. Do you know a number that can go into both 66 and 99? I'm seeing doubles, so that means that I can pull out an 11 as a factor. And 66 divided by 11 gives me 6. And 99 divided by 11 gives me 9. All right, now some more factors of 6 and 9 that they have in common. I know that 6 and 9 both share a factor of 3. And 6 divided by 3 is 2, and 9 divided by 3 is 3. So they have no other factors in common other than 1. That means I'm done factoring. Now to find my greatest common factor, all I need to do is take the product of these numbers on the outside. 11 times 3 is 33, times 1 is 1. So 66 and 99's greatest common factor is 33. Pretty quick and easy, isn't it? It sure saves you a lot of time instead of having to draw factor trees. Now, last but not least, you may be asked to find the greatest common factor of 3 numbers. Let's try finding a factor for 30, 50, and 70. Well, that seems easy. I know that one of the factors is 10. So 30 divided by 10 is 3, 50 divided by 10 is 5, and 70 divided by 10 is 7. The only factor they have left in common is 1, so that means that my GCF for 30, 50, and 70 is 10. Let's go back and try some problems on the board.
Made with Doodlecast Pro.